Hi there. Today we are going to walk through a realistic DevOps interview focused on AWS. This is not about memorizing service names. It is about how you think, how you make trade-offs, and how you handle real production situations in the cloud. I will ask you questions similar to what you would hear in an actual interview. Pause the video after each question and answer out loud before listening to the sample response. If this format helps you prepare and think more clearly under pressure, subscribe so you do not miss the next interview. Let's start with a few behavioral questions to understand how you work with AWS in real environments. Tell me about a time you had to design or operate a system on AWS that failed in production. What happened and what did you learn? A strong answer might sound like this. We had an application running behind a load balancer with instances in a single availability zone. Everything worked well until that zone had an outage. Traffic dropped immediately. The lesson was that high availability in AWS requires intentional design. After the incident, we moved to multiple availability zones, added health checks, and tested failure scenarios regularly. It reinforced that AWS does not give resilience for free. You still have to design for it. Next question. Describe a time when cost became a problem in AWS and how you handled it. A solid answer could be, we noticed a sudden spike in our AWS bill that did not align with traffic growth. I reviewed the cost breakdown and found unused EC2 instances, oversized databases, and old snapshots accumulating. We introduced tagging standards, set up cost alerts, and reviewed usage monthly. Over time, we right-sized instances and moved some workloads to managed services. The experience taught me that cost visibility and discipline are just as important as performance. Next behavioral question. Tell me about a time you had to choose between a managed AWS service and running something yourself. A thoughtful answer would be, we needed a message queue and debated between running our own on EC2 or using a managed service. Running it ourselves gave more control, but increased operational burden. We chose the managed service because reliability and reduced maintenance mattered more than customization. The trade-off was accepting some limits, but the operational simplicity was worth it. I learned to value long-term ownership over short-term flexibility. Next question. How do you handle situations where AWS best practices conflict with business pressure to move fast? A mature answer might be, I try to be transparent about the risks. If we need to move fast, I focus on protecting the most critical things first, like data safety, security boundaries, and rollback paths. I document shortcuts clearly so they are not forgotten. That way we can deliver quickly without pretending the risks do not exist. Over time, that builds trust with stakeholders. Final warm-up question. What do you do when you are unfamiliar with an AWS service that suddenly becomes critical to a project? A realistic answer could be, I start with the basics. I read the service documentation, understand the core concepts, and identify common failure modes. Then I test it in a small environment before using it in production. I also ask colleagues who have used it before. The goal is not to become an expert overnight, but to reduce uncertainty enough to make safe decisions. Now let's move into the technical and scenario-based questions. Explain the difference between an availability zone and a region, and why that distinction matters in real systems. A clear answer might be, a region is a geographic area, while availability zones are isolated data centers within that region. Zones are designed to fail independently. Placing resources across multiple zones protects you from single data center failures. If everything lives in one zone, an outage can still take your system down. Designing across zones improves availability without the complexity of multi-region setups. Next scenario. You have an application running on EC2 instances behind a load balancer. Traffic is increasing and response times are getting worse. How do you approach scaling this system? A strong answer could be, I first check whether the bottleneck is compute, memory, or something else like the database. If instances are saturated, I consider auto-scaling. Horizontal scaling is usually preferred because it improves resilience. I also review load balancer health checks and scaling policies to ensure they react appropriately. If scaling does not help, I look deeper at application behavior and dependencies. Next question. When would you choose an auto-scaling group over running a fixed number of instances? A thoughtful answer might be, I choose auto-scaling when traffic patterns are variable or unpredictable. It allows the system to adapt to demand automatically and improves fault tolerance by replacing unhealthy instances. Fixed instance counts can work for stable workloads, but they require manual intervention when conditions change. Auto-scaling reduces operational risk when configured correctly. Next scenario. Your application stores files uploaded by users. You need durability, scalability, and simple access. How do you design this in AWS? A strong answer would sound like this. I would store user uploads in object storage rather than on EC2 disks. Object storage provides high durability and scales automatically. The application can upload files directly or through a controlled endpoint. I would also think about access control, encryption, and lifecycle policies. This design avoids tying data to individual instances and simplifies scaling. Next question. How do you think about security boundaries in AWS when designing a system? A mature answer could be, I start with network isolation. I separate public and private resources and limit inbound access. Then I focus on identity and permissions. Each service should have only the permissions it needs. I avoid shared credentials and rely on role-based access. Security in AWS is layered. No single control is enough on its own. Next scenario. You deploy a change and suddenly some users cannot access the application, but others can. There is no obvious error. What is your first instinct? A realistic answer might be, I suspect a networking or routing issue. It could be related to security groups, routing tables, or load balancer health checks. I check logs and metrics to see if requests are reaching the instances. I also verify that the change did not affect only one availability zone or subnet. Partial outages often point to configuration mismatches rather than total failures. Here is the next scenario. Your application depends on an RDS database. During peak traffic, latency increases and connections start timing out. CPU usage on the database is not maxed out. How do you approach diagnosing this? A strong answer might sound like this. I start by looking beyond CPU. Databases often bottleneck on connections, I/O, or locks before CPU becomes an issue. I check connection counts and see if the application is opening too many connections or failing to reuse them. I look at disk I/O metrics to see if read or write latency is increasing. I also examine slow query logs to identify inefficient queries that only become problematic under load. If needed, I adjust connection pooling, add read replicas, or optimize queries. The key is identifying the real constraint rather than assuming compute is the problem. Next question. You are designing a system that must survive the loss of an entire availability zone. How do you validate that your design actually works? A thoughtful answer could be, I do not assume the design works just because resources are spread across zones. I validate it by testing. That might mean temporarily disabling instances in one zone or simulating failures through controlled experiments. I verify that load balancers stop sending traffic to unhealthy targets and that auto-scaling replaces instances correctly. I also test stateful components to ensure they fail over as expected. Validation is critical because configuration mistakes can silently undermine zone-level redundancy. Next scenario. You notice that an application deployed on ECS is restarting frequently, but there are no clear error messages. The tasks appear healthy at first and then restart. What do you investigate? A strong answer would sound like this. I start by checking container logs and task events to see why the restarts are happening. Often, it is related to memory limits or health checks failing. I verify whether the container is exceeding its memory allocation and getting killed. I also review health check configuration to ensure it allows enough startup time. If the application depends on external services, I check whether transient failures are triggering restarts. The goal is understanding whether the restarts are caused by resource limits, misconfiguration, or application behavior. Next question. When would you choose to run workloads on EC2 directly instead of using a managed service like ECS or EKS? A realistic answer might be, I choose EC2 directly when the workload has very specific requirements that managed services do not support well, such as custom networking, unusual storage needs, or specialized hardware. EC2 can also make sense for legacy systems that are difficult to containerize. The trade-off is increased operational responsibility. Managed services reduce overhead and standardize operations, but they also impose constraints. The choice depends on whether flexibility or simplicity is more important for that workload. Next scenario. Your system uses multiple AWS services, and an IAM permission change causes a partial outage. Some actions succeed, others fail silently. How do you prevent and debug this class of issue? A strong answer could be, I prevent it by using least privilege with careful testing. Any IAM change should be validated in a non-production environment first. For debugging, I enable detailed logging and look at access denied events in CloudTrail. Silent failures often happen when applications catch permission errors and retry indefinitely. I trace the failing requests and map them back to the required permissions. Long-term, I prefer using infrastructure as code and version policies, so changes are reviewable and reversible. Next question. You are asked to design a multi-region architecture for disaster recovery. The business wants minimal downtime, but also wants to control costs. How do you approach this? A thoughtful answer would be, I start by clarifying recovery time and recovery point objectives. If near-zero downtime is required, active-active architectures make sense but are expensive and complex. If some downtime is acceptable, I design an active-passive setup where one region handles traffic and the other stays warm. Data replication strategy depends on consistency requirements. I also design regular failover tests because disaster recovery that is never tested is unreliable. The final design balances cost, complexity, and risk based on business priorities. Final question for this section. How do you decide which AWS failures you design for and which ones you accept as unlikely? A mature answer might be, I design for failures that are common or have high impact. Instance failures, zone outages, and misconfigurations happen frequently enough to justify planning. Extremely rare failures can be acknowledged but not fully engineered around if the cost is too high. I communicate these decisions clearly so everyone understands the assumptions. Designing systems is about managing risk, not eliminating it entirely. Let's move into the pressure section. These questions are designed to reflect situations where AWS systems are under stress, information is incomplete, and the cost of the wrong decision is high. Here is the first scenario. Your production workload is running in multiple availability zones. Suddenly, one zone starts showing elevated latency and intermittent failures. The application is still mostly working, but user complaints are increasing. You are not sure if this is a zone-level issue or an application issue. What do? A strong answer might sound like this. I start by isolating impact before trying to diagnose root cause. If traffic can be shifted away from the affected zone safely, I do that first to protect user experience. Then I compare metrics across zones to see what is different. That includes instance health, network latency, and error rates. I avoid making deep architectural changes until I understand whether this is a localized AWS issue or something introduced by our own deployment. Stabilization comes first, investigation comes second. Next scenario, your AWS bill suddenly spikes overnight. Leadership wants an explanation immediately, but you do not yet know what caused it. Some teams are worried about shutting things down too aggressively. How do you handle this? A thoughtful answer could be, I acknowledge the issue quickly and focus on visibility. I check Cost Explorer to identify which services or accounts are driving the increase. If I see runaway usage, like an auto-scaling group gone wrong or a misconfigured data transfer path, I cap or throttle it carefully, rather than blindly shutting things off. At the same time, I communicate clearly that we are investigating and mitigating. Cost incidents need urgency, but they also need restraint to avoid breaking production systems. Next pressure question. You are in the middle of an incident when AWS announces a regional service degradation. Some of your systems depend on that service, but others do not. How do you decide what actions to take? A mature answer would be, I first map which parts of our system are affected by the degraded service. If some components are healthy, I avoid touching them. For the impacted parts, I decide whether we can degrade gracefully, fail over, or temporarily disable features. I rely on what we practiced during drills rather than improvising. If failover is possible and tested, I use it. If not, I focus on reducing blast radius and keeping core functionality alive. Clear communication with stakeholders is critical, so expectations are managed. Next scenario. A security team flags a misconfigured IAM policy in production. Fixing it immediately could break several services. Leaving it as is carries security risk. How do you approach this decision? A strong answer might be, I treat this as a risk trade-off between availability and security. I first assess how severe the security exposure is. If it is actively exploitable, I prioritize fixing it even if it causes disruption, but I try to stage the change carefully. That might involve rolling out the policy fix incrementally or adding temporary compensating controls. If the risk is theoretical but not immediate, I plan a controlled fix with testing and communication. The key is not ignoring the risk, but also not causing unnecessary outages. Final pressure scenario. You are asked to make a call on whether to fail over to a secondary region during an ongoing AWS outage. Failover is expensive and risky, and you know recovery might take hours. Staying put risks extended downtime. How do you decide? A realistic answer would be, I base the decision on impact and confidence. If the outage is already breaching our recovery objectives and the secondary region has been tested recently, I lean toward failover. If failover has not been exercised or data consistency is uncertain, I am more cautious. I also consider user impact. If partial functionality is acceptable, I might delay failover while monitoring closely. Whatever decision I make, I communicate it clearly and own the outcome. Indecision is often worse than a well-reasoned call. That brings us to the end of this AWS-focused interview. These scenarios are meant to reflect how real cloud incidents feel, where there is no perfect answer and every choice has consequences. What matters most is how you reason through uncertainty, communicate risk, and prioritize stability. Take a moment and think about which question challenged you the most. Was it handling partial zone failures, deciding on a risky failover, or balancing security against availability? If this format helps you practice real-world thinking and prepare for interviews, make sure to subscribe so you do not miss the next session.